Question number 8. It says two small iron particles, each of mass 280 milligrams, are placed at a distance 10 centimeter apart. If 0.01% of the electrons of one particle are transferred to the other, find the electric force between them. Atomic weight of the iron is this much, 56 grams per mole, and there are 26 electrons in each atom of iron. Clear? So here we will require some basic concepts of chemistry like moles, how to calculate number of moles and all. Okay. First of all, let's go into finding the number of electron in each 280 milligram of iron. Okay. So first of all, to find or calculate the electrons, this is a particular method. We will find moles. So what is the given mass? Given mass here is 280 milligrams. 280 milligrams. And what is the molecular mass of iron? Molecular mass is 56 grams. So be very careful. You have to convert here. So molecular mass of iron will be given here 56 grams per mole. Now, if this is 56 grams per mole, what we have to do? We have to find number of moles here, right? So number of moles is given mass upon molecular mass. So it is 280 divided in milligrams. So 10 to the power minus 3 whole divided by 56. Correct? So this will be your total number of moles. Now each molecule has how many number of molecules? 6.022 into 10 to the power 23, right? So number of molecules of iron present in these number of moles will be 6.022 into 10 to the power 23 multiplied with number of moles here. Correct? Okay, great. Now, if this is your number of molecules, each molecule contains how many electrons? 26 as per the question. So, what will be the total number of electrons? Number of electrons will be 26 multiplied with these number of molecules. So, 6.022 into 10 to the power 23 whole multiplied with 280 upon 56 into 10 to the power minus 3. Correct? These are the number of electrons. So let's simplify it. Okay. So simplifying it will be 56 and 280. Let's cancel out this and see how much we get. This will give us 5, and 5 into 26 if I do 130 into let's multiply 6.022, or let's just make a rough approximation. It will be 780 into 10 to the power 23 minus 3 will be our 10 to power 20. Correct? These are the number of electrons. Now, the question is saying how much out of these electrons? 0.01% of the electrons, okay, are transferred. So, let's find how much is 0.01%. So, 0.01% of electrons means 0.01 into 100 upon 100 into 780 into 10 to the power 20, correct? These two zeros and 10 to the power 20, I am just reducing this, okay, and making it here as 10 to the power 18, correct? And 780 into 0.01, that will give us 7.8. So 7.8 into 10 to the power 18 electrons are transferred. Not the charge. Be very careful. This is electrons and not charges. So how will you calculate charge? We know the basic formula, Q equals to NE. Okay. So let me write here. This is our number of electrons which are transferred. These are electrons present in those number of moles or molecules. These are the electrons which are transferred if you read the question carefully. So this will give you Q equal to N. N is 7.8 into 10 raised to 18. And what is the charge on one particular electron? 1.6 into 10 raised to minus 19. So when you multiply both, you will get the total charge. And let's see what is the product giving us. 7.8 into 1.6, that will be 12.48 into 10 to the power minus 1. Correct? This is our total charge Q. So we can remake it here as 1.248 into 10 to the power, or 10 to the power will go. So this is our total charge which is transferred from each atom. Let's read the question once more. Two small iron particles, each of mass this much, are placed at a distance 10 centimeter. If these number of percent of electrons from one particle is transferred to the other, then you have to find the force between them. So each particle has a charge of 1.248. So let's find the force. So force will be K Q1 Q2 whole divided by R square. What is R? 10 centimeters. So 10 into 10 to the power minus 2 whole square. 10 to the power minus 2 because it's given in centimeter. Let's simplify it. So first of all, our let's multiply 9 into 1.248 into 1.248. So this will be 14.01. Okay, 14.01 or 02. Okay, we can make it into 10 to the power 9 whole divided by, this will become 10 to the power minus 1 whole square, right? 10 into 10 to the power minus 2 is 10 to the power minus 1 whole square, which is nothing but 10 to the power minus 2, and 10 to the power minus 2 goes up and it will be 14. Approximately I am writing 14 into 10 to the power 9 to 11, correct? So this will be our net force between these two.